In this video, I'm going to show you how to set up, use, and test Postgres and Drizzle inside of a Hono REST API. I'm going to build out the database functionality inside of a simple to-do app, and by the end of this video, you'll have everything that you need to set up Drizzle and Postgres inside of your own Hono apps. I'm going to quickly walk through the tutorial outline so you know exactly what to expect in this video. I have also added chapters to the video so you can easily jump around and watch the chapters that are most helpful for you. So we'll start off with local Postgres database setup using Docker. Then we'll move on to connecting to our database with Drizzle. And then we'll move on to Drizzle schemas and migrations. And then seeding our database with Drizzle, querying our database with Drizzle, and then setting up and destroying a Postgres DB for testing purposes. And then we'll create a database reset script for local development. And then we'll move on to fetching data inside of a Hono route. Finally, I have provided a link to the finished code in the description of this video so you can review it and copy any of the code that you like. The code is free to use. Let's go ahead and create a new Hono app from the command line using bun. Perfect. We've got our project, so let's open it up. So here's our project. Let's take a look at what we've got. We've got an index.ts file with a hello Hono route, and then inside of our package JSON, we can see we have a dev script to start up our local dev server, and that's pretty much it. So the first thing I want to do is get our database up and running, and to do that, we need Docker. So if you don't have Docker installed, you can come install it on their website, docker.com, come check out this button and then pick out the one for your operating system. And if you're not familiar with what Docker is, it's a containering tool. And so the way we're going to use it is it enables us to quickly spin up Postgres databases. It'll spin up the database in an isolated container with all of the software that it needs. And then when we're done with that container, we can delete it or shut it down very easily as well. So this is a very handy tool for local development. So now that we have Docker installed, we can create a Docker Compose file here in our project. And this allows us to create a set of instructions on how we want Docker to create a container. So we can specify some services, and we could specify multiple, so we could spin up a REST API and a database, but for our situation, I'm just going to spin up a database. So then we need to specify an image, and this will be a Docker image that is downloaded from Docker Hub. So Postgres has some official images on Docker Hub that we can download and use for free. So when I specify 17.5, that is the version of the version of Postgres that I want. And I also want the Alpine version, which means it's more lightweight and it has less software included, which means it'll download faster, which is really good for local development and especially local testing. So then the next thing that we need is a restart policy. And for me, I prefer unless stopped. So I want my Docker container to keep restarting unless I stop it specifically. And then we'll also need to specify some ports. Now, this is really important because our Postgres database is running inside of a container on port 5432. That's this number right here. But we can't actually access it, so we need to port forward it so we're mapping it to port 5432 to our operating system. So that's what's happening right here. We are exposing our database from the container to our operating system. Then the next thing we want to do is set up a couple environment variables. So we're going to need to set up a password for our database, a user, and the name of the database. Now, you might be thinking, password and user, that doesn't sound very secure. We shouldn't be using that. But this is all for local development. So I'm not deploying this database anywhere. And so it doesn't really matter what we put for our password and user. So this is perfectly fine. And now that our Docker Compose file is done, we can run it. And this will start up our database. So let's do that. We can open up our terminal and we can say docker compose up -d, and we can see it pulled the image and it started up the container. So let's take a look. So now I'm taking a look at Docker Desktop and we can see we have a container up and running. So if I expand this, we can see that our Postgres database is here. It's live. So we have our 17.5 Alpine and it is exposed on port 5432. So this is great. We now have our database up and running and it is accessible to us. So what's the next step? Well, now we are going to take a look at Drizzle, and we're going to use Drizzle to connect to our database. So here I'm going to show you the Drizzle documentation really quick. They have a step-by-step guide on how to set up Drizzle with Postgres. So these are the steps that we're going to need to follow. So step 1 is we're going to need to install all of our packages for Drizzle. Step 2, we'll need to set up our .env file. Step 3 will then connect Drizzle to the database, and they have this easy option where you just plug in the URL, but I'm actually going to use this pooling option. This allows us to set a maximum number of connections to the database, which prevents the database from getting overwhelmed, which is better for a production use case. So that's what I want to show you in this video. And then step 4, we need to set up our schemas, and these will be our tables in our database. And then step 5, we'll need to set up our Drizzle config. Step 6 will then be to generate migrations and then run the migrations, and that's what will put our tables into the database. And then finally, step 7, they have seeding and querying the database. So we're going to walk through these together and get our Drizzle connection set up. Let's go ahead and get everything that we need installed for Drizzle. So I can do bun add. And then there's also a couple of development dependencies that we want to add in here. So for development, we do -d. Now that we have everything installed, we can go ahead and create our .env file. And inside of here, we are going to need a database URL variable. And then for this, we are going to say Postgres QL // and then we're going to do the user and password, and that comes from our Docker Compose file. So we have called our user and our password and our database of to-do. So we are going to do user :password at localhost, and remember we are port forwarding 5432, and then the name of our database is to-dos. So this URL will be able to connect us to our running database inside of our Docker container. So the next step for us is to set up our database connection with Drizzle. So I'm going to create a new directory in here called db, and then a new file called db.ts. And this is where I'm going to store the connection. So first we need to import Drizzle and pool. Now that we have those, we can set up our pool. And inside of here, we're going to need our connection string. And this is the database URL that we just put into our env. And then I want to set a maximum number of connections as 10, as to not overwhelm the database. And then finally, my last config here is I want to set an idle timeout. That way, if any connection sits idle for too long, it will be taken away and put back into the pool. So that'll keep our resources free. Now that we have the pool set up, we can plug that into our Drizzle function. And I'm going to add a config here called casing and set that to snake case. And the reason why I'm doing that is because inside of TypeScript and JavaScript files, we primarily use camel case, as you can see here. But inside of databases, it's more common to use snake case for the names of the columns and the tables. So this nice little config will make it so that Drizzle will use snake case inside of our database tables, but we can use camel case inside of our application code. So now that we have the database connection set up, we can set up our schema file. So we'll do that here in our DB folder. And this demo app is a to-do list demo app. So in a normal to-do app, you might have a users table and a to-dos table. So that's what I'm going to set up here. And users can have multiple to-dos. So let's set up our user table first. And then we'll need to import the PG table from PG core Drizzle. And then we can say the name of the table in the database will be users. And here we can establish our columns and their data types. So we definitely want an ID, and I want this to be a UUID. And lucky for us, there is a UUID option here from PG Core. So we can select that one. And then we can label this as the primary key by chaining that function on. And then we can also default this to random. So that way we don't have to provide it. The database will set it automatically for us. Then a user would have like an ID, an email, a password. So let's go ahead and add those as well. And the email will be a varchar, which stands for variable character. And that basically allows us to set a limit. So somebody can't have an email that is 10,000 characters long. That would probably be a fake email. And so we can limit that and help protect our database from spam emails. So let's just set a length maximum of 256. And we want this to be unique because we don't want multiple users with the same email. And this is required. So we'll say not null. Then we want to say that there's also going to be a password hash. And this can also be a varchar. and we can set a limit length here of, let's say, 500. It shouldn't ever be more than that. And then this one should also be not null. Then let's add on the age, for example. We might want to keep track of user's age, and we can pull in the integer from pgcore. And we can say that one is allowed to be null. It's optional. And then it's good practice to add a created at and updated at column as well. So let's do that. And we can do a timestamp, import that from pgcore. And we can add some options in here. So one option would be with the time zone, just for improved accuracy. So let's do that. And then we can default that to now, which is nice. So when it's created, it'll just automatically default. And we can do, it's actually going to look about the same for updated at. So I'm going to just copy that line down, updated at, and default to now with the time zone. So that's looking pretty good. One other thing I want to mention here is, what if somebody enters an age of 10,000 or -5? We're not checking this or enforcing any kind of limitations here. So just to show you that Drizzle can also do this, we can add a constraint down here. So to do that, we put the table in, and then we put an array, and then we can add a check, and we'll import check from pgcore, where we're importing everything else from. And in here, we can say we'll have two different checks. So first, we'll check that they're less than 120 years old. So age check 1 is the name of the check. And then we'll use Drizzle's SQL function. So if I type SQL, we can see the import here from Drizzle ORM. So let's get that imported. And then we add backticks, and we can put our logic inside of here. So we can reference the table.age, and you can see we're getting that autocomplete too. So these are all of our columns that are available to us. And we can just say less than or equal to 120. So if the database ever gets a number greater than that, it's going to throw an error. And then we can add a second check. We'll just call it age check 2. Backticks table.age, and make sure that it is greater than or equal to 0. So this is how you can add some extra enforcement around your data and keep your data clean and safe from users entering in potential junk. So that's looking pretty good for our users table. Let's take a look at what our to-dos table will look like. So let's first declare the to-dos table, and this will be the same, the PG table, and then we'll name it to-dos, and that'll be the name in the database. And then we can declare our columns. So here I'm also going to want an ID, and this is going to look just like this one, so I'll copy that down. And then we're going to want to reference the user ID up here in this table, because to-dos belong to our users. So here we can do that with Drizzle as well. And we can say user ID is a UUID, and it is not null. We want to make sure we're enforcing this value, and we can also put references. Oh, I'm not getting autocomplete because I forgot parentheses there. References, and then we can tell it to reference the users table dot ID, and we can set up some config with this and say on delete, what do we want to do? Well, if we delete the user, let's cascade that and delete all of their to-dos as well. So this is starting to come along. And now what we can do is say for a to-do list app, to-do should probably have a title and a description. So let's add those columns, title, and this can be a varchar as well. Let's limit the length. We don't want some 100,000 character title taking up space in our database. So title really shouldn't be more than 500 characters. And we'll make sure that's enforced. We don't want to do without a title in the database. But we can say that the description can be optional. Sometimes the pop-ups get a little bit annoying there. So varchar description, and let's say the description can have a length of 1,000 characters. Might need to be longer than the title. And we also want to know if our to-dos are completed or not. So this would be a Boolean. We need to import that from pgcore. And we'll default it to false. I'm assuming that if somebody's adding a to-do to their to-do list, it's because they haven't done it already. So it makes more sense to do it that way. And then we can copy the created at and updated at as well. And there we go. So we now have our schema all set up. With our schema all set up now, we can add our Drizzle config file. So that will go in the root of our project, and it is called drizzle.config.ts. And then inside of here, we need to import the define config from Drizzle. And now we can export that config. And inside of here, there are a few things we're going to need. We'll need an out. And out, what this means is provide it the path where you want Drizzle to put the generated migrations and metadata that it stores. So for us, we want to store this here in source/database, and then the name of the folder will be Drizzle. And then in addition to out, we need to tell Drizzle where our schema file is located. So we can choose schema, and then we can put the path ./source/db and schema. And then we also need to tell it what the dialect is, which, as you can see here, PostgreSQL is our option. And then we need to provide it the database URL here as well, database credentials. And we can say URL is process.env.database URL. And then the last thing is I also need to add snake case here. And TypeScript is upset because the database credential URL is string or undefined because the environment variable could possibly be undefined. But we know that we have this environment variable set up, so we can just put an exclamation point here to make TypeScript happy and basically tell it that we're confident there is a value here. So now that we have our Drizzle config set up, our schema set up, our database connection set up, we can finally create and run some migrations. So let's jump over to our package JSON, and I'm going to add a couple scripts here. So first will be database generate migration, and then here we'll need to call drizzle kit generate. And then I want to add another one to run the migration. So database migrate and also drizzle kit. And then a third one to spin up the Drizzle Studio, which allows us to interact with our database. So if you're not familiar with what migrations are, basically we have our schema file, which is written in TypeScript, and a migration for Drizzle, it's going to read this and it's going to turn it into raw SQL. And then we'll have this SQL file that can create this table and all the columns in our database. And then once we have that file, we run the migrate script, which will then actually run that SQL inside of our database and create everything. And then we can use Drizzle Studio to look at our database and make sure everything is working and happened as expected. So let's go ahead and run this migration script. So I can do bun run database generate migration. And there we can see the output. So it used the default drizzle config, it read our config, and then it created a migration file. So we can see here in the database folder that we now have this drizzle folder. And there's some metadata in here that Drizzle keeps track of. And then here is our SQL file. So let's take a look at this. We can see create table to-dos, and these are the columns we specified. So ID with a random UUID, user ID, title, description, completed, created at, and there's our users table. So this is all of the raw SQL. Now we want to run this file inside of our database, and that is what this script is for. So let's run this. And it says migrations applied successfully. Cool. So let's run bun run database studio, and here now we can go to local Drizzle Studio and take a look. So here we are looking at Drizzle Studio, and this is super cool. We can see that our migrations worked, and that is because we have a to-dos table and a users table. And we can see in to-dos we have all of our columns, ID, user ID, title, description, created at, updated at, etc. We've got all of the different columns for our users table as well. So this is our window into our database, which is pretty cool. So our database is up and running. We've connected successfully. We've run our migrations. We've got tables, but we don't have any data. So it's hard to write queries for your app when you don't have any data to write queries off of. So that's our next step. We are going to seed our database with some fake but realistic data so that we can actually do some good local development and create queries. I wanted to quickly show you the Drizzle documentation for seeding. So they have an entire section of their documentation dedicated to seeding the database, which is really nice. So if we take a look at some of these basic examples they have here, there is a seed function that we import from Drizzle seed, which we imported earlier, and then you can call that with your database connection and your tables. And if we keep scrolling, we can look at some more advanced examples. So here we have an example where there are users with posts. Now, this is what we're going to want to do. Something similar to this, because in our to-do list, we have users who have to-dos, and we want to create those at the same time. And if we keep scrolling, they have more advanced examples down here at the bottom that start to get pretty wild. So here you can specify minimum values, maximum values. You can specify certain strings to be picked from. And they even have more advanced weighted randoms, which is pretty cool. I'm not going to do that here today, but if you ever needed something more advanced like this, they've got you set. So let's go ahead and jump back over to our code and we'll create a seed script. So now we're ready to put our seed script together. I'm going to create a new directory called scripts. And the reason why I'm not putting this script in the database folder is because this is for local development only. It's not really part of our application code, so it's better to keep it separate outside of the source directory. And in here, I can say seed script.ts. And now we can go ahead and import our database and our schema and the seed function that we need. Now that we've got those imports, we can declare a function, and then we're going to immediately call this function at the end of the file. That way we can put this into our package.json and just run the script. Now, just as we saw in the documentation a moment ago, we'll do await on the seed function and we'll provide it the database from our DB file, and then we'll provide it the schema. And then we need to do a refine function on this because we want each user to have to-dos associated with it. So call that refine functions. And then inside of here, we'll get the users table. That autocomplete is so nice. And then we'll specify columns of just an empty object. And then we can do our count. Let's say 10 users. That is good enough with to-dos table of 10 to-dos. So we should have 10 users with 10 to-dos each, which would be 100 to-dos in our database when this is all said and done. And then down here at the bottom of the file, like I mentioned a moment ago, we want to call this function cd database, and we're going to await it because actually we're not going to await. We're going to do a dot then and dot catch, because otherwise if I was going to await it, I would have to wrap this in another function, which I don't want to do. This is a little bit cleaner. And we could say console.log database was seeded successfully. And then the next thing that I want to do here is actually close the pool. So return pool.end. and that is why we imported the pool from up here. Otherwise, when we run the script, it's going to connect to the database, run the seed, and then it'll hang because we're not actually closing down that database connection after. And then we can do our .catch. So if there is an error seeding our database, then we can log out that error. And we can also return pool.end. There we go. Now, if we go over to our package.json, here we can add our seed script. So we'll call it database seed. And we can say bun run, because bun can run TypeScript files natively. We don't need to transpile it first. Then we can just simply call this file. So in the root of scripts / seed script.ts. All right, that should do it. Now let's go ahead and run this. And I've still got Drizzle Studio up, so I can open up a new terminal. Bun run database seed. So let's take a look at what we got. We got an error, and the details: failing row contained an ID, an email address, another ID, and a negative number, and 2 timestamps. So we can see that our age check failed. It tried to insert this negative big number in for the age when we're restricting it to somewhere between 0 and 120 years old. So we're going to have to update our seed script so that it's not trying to put in these random numbers. All right, let's jump back over to our seed script and get this to put in more accurate ages. So inside of the columns, we can add age, and we can tell it using the built-in functions, that I want an integer and I want to set a min and max. So there we get the minimum value. Let's set that to 0. And we can do the same thing with the max value and set that to 120. There we go. So let's try running our seed script again and see if it will work. All right, look at that. We got database seeded successfully. So we know it ran. Let's go ahead and jump over to our Drizzle Studio and see what we got. So back over here in Drizzle Studio, I can see that I now have data in my database. Super cool. If you're not seeing anything, go ahead and click the refresh button and it should pop up. You can see over here it's still showing 0 and 0, so I need to click refresh there, and now I can see the totals. We have 10 users and 100 to-dos, which is exactly what we were expecting to get. So if we just kind of like look at this data to see what we got, we have UUIDs, so that looks good. We have emails, and these all are fake but realistically looking emails, so that's great. Hash passwords, which are fake, but they serve the purpose. The age range, so there we go, 0 between 120. Nobody is outside of that, causing our checks to fail. Our timestamps look good. And now let's check our to-dos and see what we have here. So here we got UUIDs. That looks good, and they're linked to different users. But the title and the description here, you can see, are just a blob, a random string generated with numbers and letters, and I don't like that. I want my fake data to look more realistic and have a more realistic looking title and description. So we'll change that in a second, but let's keep looking. So completed, true and false, Boolean, that looks good, and the timestamps look good. So let's just make a couple improvements around the title and description. So we can improve our fake data by jumping back into here and specifying some values for our to-dos table. So we can set our object here and we can choose our columns. And the problem columns were title and description. So let's go ahead and choose title first, and we can do the funcs, and we can pick value from array. And from here, we can actually specify a handful of values that we want it to choose from. So let's go ahead and say values, and this is an array. And let's just say buy groceries. And these are titles for to-dos, so let's make them seem somewhat realistic. Walk the dog, read a book, write some code, go for a run, and that's probably good enough. So then we can add the description below, and we can do the same thing. Functions dot values from array, specify our values, and say maybe the description will walk the dog very carefully, or very focused, or remember to stretch, and keep things clean. All right, there we go. We've got some goofy descriptions for our different titles for our to-dos. I also want to quickly add the reset function in so that we clear out that old data before we start inserting new data. Import that from Drizzle seed, and this also needs the database and the schema. So if we save that and then we try rerunning our script, we can see our database was seeded successfully. So let's take a look. So back in Drizzle Studio, if I click refresh, there we go. All right, we can see the title and description now have those various options that we put in. And so this is looking a lot more realistic, which is awesome. So here I'm feeling like the seed script is good enough and we can move on. So it is time to write some queries. So another cool thing about Drizzle Studio is that we can actually build out our queries right inside of here. So if you see this Drizzle runner, we can click on this and it brings us over to a screen where we can prototype and run queries on our database. So this is awesome. They have this defaulted select 10 items from the to-do table, and if we run that, we can see, it's giving us back these 10. Now, for this app, I want to have two queries that I want to build out. One would be to get all of the to-dos by a user ID, and then the other one would be to insert a to-do for a user. So let's go ahead and see if we can build those queries out here. And let's start with getting to-dos by a user. So think of this just like regular SQL. So we can do database.select, and then we can choose from our table, so our to-dos table, and then I want where the ID equals a given user ID. So here's a user ID. Let's go ahead and just copy this, and we can copy it by clicking show JSON. So grab this user ID, and we can say where, and then there's equal. And you can see that we're getting autocomplete in here too, which is super nice. And we'll say the to-dos dot user ID equals a given user ID. And let's just go ahead and click this prettify button, make it a little cleaner. And let's go ahead and give this a try. So I run this and we can see our results. All of the user IDs are the same one that I put in up here, and we're getting back 10 of them. So our query is working as expected. We're getting all of the to-dos for this user. The thing is, we're getting them out of order. If you look at the created at, we have 2023 up top, we've got 2025, 26, they're all kind of scrambled. So we can order this by descending. So the most recent to do is at the top. So there is an order by function, and we can say descending and then to-dos dot created at. And let's run this query again. And there we go. We can see our most recent to-dos are up top going down to the oldest ones. Cool. So this is exactly what I want. Let's go ahead and write up our next query. I want to be able to insert a to-do for a user. So database.insert, and then insert has values on it. And the value will take an object for the different columns. And so if I do that, it's saying it is expecting to insert into the to-dos table. So there we go. And here I can hover over. It's even giving us warning messages, which is great. So we can see here insert into to-dos, and here are our different columns. So that's really handy. And I'm getting autocomplete here. So to insert a to-do, let's say I need the user ID, definitely need that. And we're going to insert a to-do for the same user that we just selected all of the to-dos for. And then we'll have the title. Let's say clean the basement. And we can add a description as well. So vacuum and put away baby toys. And those are all of the required fields. If I were to come down here, we can see completed. We default that to false. We default created at and updated at, and the ID also is assigned a random UUID. So we don't need any of those values. This should give us exactly what we need. So click the prettify button and let's run this. Executed, no rows. Okay, so how do I know that this actually worked? Well, let's go ahead and run this function and see if our new value is in there. And there it is, right in the middle. Clean the basement, vacuum, and put away the baby toys. So it did insert, so that's good. But instead of just returning nothing, I would like to see the return value. So there is a way to do that. We can do dot returning, and then we can prettify, and let's go ahead and run this query again. And there we go. We get the result. And so we'll be able to show the user what they had just inserted into the database. Perfect. So as you can see, it was pretty easy to prototype out our queries here in Drizzle Studio. Now the next step is to basically copy paste these and put them into our VS Code application code. So back over here in our application code, I'm going to create a queries .ts file. So here we're going to be able to put those queries that I just copy pasted them over from Drizzle Studio. So for now, I'll just comment that out. But we're going to, let's start with the first one of selecting the to-dos. So we can say we'll need a new function, get to-dos by user ID. And this will need to be an async function because we're making a database call. And this is going to take the user ID, which we can put that as a type of UUID. And I'm not seeing the import I want, but there is a type of UUID from the crypto package. And I need to specify that as the type UUID. So there we go. Now it's happy. And then we can import our database. There we go. And then we can take this, put that in here, and let's uncomment it. And we're getting a few red squigglies. So this one cannot find to-dos. We actually need to import our to-dos table from our schema. So that's exported here, to-dos table. So let's bring that in. All right, got the import. And then we need to import this equal function. And this would be to-dos table. Let's see if I can get this equal from Drizzle ORM. There we go. And just, yeah, descending from Drizzle ORM, and this to-dos table dot created at. And then let's see. We don't want this hard-coded user ID. That will be the user ID that's passed in right here. So we'll just say user ID. And let's set this as to-dos. And if we hover over it, let's see how it's working for us. So we need to add an await statement because it's not showing us the actual results there. There we go. So now we can see to-dos is ID, user, title, description, and it is an array of to-dos. And then we can just return the to-dos. Perfect. So that should be working. Now let's go ahead and build out our other one, our inserting a to-do for a user. And this one, we're going to need to supply any of the values to create a to-do. So we'll say to-do, and then let's go ahead and make a type for a new to-do. And to create a new to-do, we're going to need, let's take a look at our schema. We'll need the user ID, title, and description, and completed are optional. So user ID is a UUID, and then our title is a string. Description is an optional string. And last, completed is optional, and that is a Boolean. All right, now we can put that here as the new to-do. So now whenever we call this function, we'll know exactly what needs to be provided. And we can then copy paste the query we prototyped in Drizzle Studio and bring that over here and uncomment it. And we'll need to await this as well. And this will also be to-dos table. And we can say this is going to return the to-do. We'll say created to-do. Otherwise, we'd have a conflict with that to do. And save for some formatting. Let's see here. So then we will pull off all of these different values from this to do, which means we can actually just delete that and put to do in there. And TypeScript is happy, so things are looking good. And then we can return our created to do. And if we hover over this, we can see it's returning an array of to-dos, which actually we're only inserting one to-do, so I would expect this to just be the object and not an array. So we can destructure and pull that one to-do out of that array. And now if we hover over the return, we can see that it's just the single to-do, no array. So that's a little bit cleaner for us. So okay, we prototyped these out in Drizzle Studio, so I'm pretty confident they're working, but it would be good to have some automated tests to actually prove that these queries are working inside of our application code. So let's create a queries test file and then write some tests for these. All right, I'm going to create the queries test file here in the same directory. And if we do .test.ts, then the bun test runner will pick this up and run tests on it. So that's the naming convention we want to use. And I'm going to use the bun test runner, so I need to import a couple of things. And we can get the describe, test, and it from bun test. And then we're also going to want to import our query. So we'll get the insert to do and get to dos. Insert to do and get to dos by user ID. All right, and then we can set up a describe block, and this one will be for, let's start with insert to do. And then inside of this describe block, we can do an it for a test and say, we'll start with the happy path. It should insert a to-do into the database. And this is going to be an async function. And then what we'll want to do is say await insert to do. We'll call our function. And we know that after inserting the to do, it's going to give us a to do back. So, of course, we need to provide it some data. And so let's go ahead and create a const right here. Call it new to do. And give it the values that it needs. So we also have a type for new to do as new to do. Okay, I need to export that type. So let's do that really quick. Export, and then I can import that new to do type. There we go, bring it in. And now it's going to tell us exactly what we need on here. So we'll need the user ID. So I copied a user ID that is already in our database, and this is the one we were previously testing with in Drizzle Studio. Now, the thing is, this is actually not good practice. So we're going to fix this in a moment, but I just want to quickly get this thing to run and see that the test can work. And the reason why it's not good practice is we don't want to use hard-coded IDs for something in our database. We actually want to spin up a test database. So I'm not going to do that right away. We're going to do that in 1 second after I get this test set up. So we also need a title. So we'll just call this test to do. And a description is optional. This is a test to do. And completed. And actually, we'll leave that off. Let it default to false there. All right, and then we need to provide that new to do here to our function. And then we can write some expectations around this. So if we hover over, we can see exactly what we're going to get back. Let's say we're going to expect there to be an ID, because that means the database successfully created an ID for us. To be defined. And oh, I forgot to bring in expect. I put test there. Okay, there we go. So now we don't know we know it's a UUID, but we don't know exactly what it's going to look like. So that's why I'm just going to say to be defined. And then we do know that the to-do dot user ID should match with our user ID up here. So we can say to be our new to-do dot user ID. And that is good enough for the moment for our initial test. So let's go ahead and run this test using bun test and see what we get. All right, it passed. And if I run it again, we passed again. Cool. So we can check out Drizzle Studio to see if we can actually find this in the database. All right, so back over here in Drizzle Studio, let's see if we can find those to-dos that we created from our test. And there they are. So test to-do 1 and 2 from the 2 runs that I did. Awesome. So we know that the code is working inside of our application just as well as it was working here where we prototyped it. So this is good, but the problem is we need a test database because we want to be able to spin up a test database, insert the data we need, expect the results, and then tear down that database. Otherwise, we're just going to get a bunch of junk test data filling up our database here, which we don't want. So now I'm going to set up the test database. So I'm going to create a new directory inside of our source called test, and that way I can keep any kind of test helpers inside of this file or this folder. And we'll create a setup test database.ts file. And inside of here, there are going to be a few different functions. But first, let's create a function that will make our test database. And then we'll make a function to tear down our test database. And then we can import these into our test and use them where we need them. So first, here we have a create test database function. Now, what we're going to need to do is spin up a new test database. And inside of our Docker container, we have a Postgres server. And that server can contain multiple Postgres databases inside of it. So we actually want to connect to our Postgres server using an admin connection and then spin up a new test database. So to connect to our Postgres server with an admin connection, we can do this. Now, this is looking very similar to our other connection, except here on the very end, there is a Postgres database option. Whereas with our Docker Compose, we set up a to-dos. So this Postgres database option is there by default, and it's used for admin connections. So for things like what we're doing right now, creating a test database. So we could actually move that to a .env file And why don't we go ahead and do that? And we'll call it our admin database URL. There we go. Now we can delete this and use process.env and copy that to get our admin URL. Cool. So now what I want to do is create a randomized test database name. So to do that, let's say test database name, and we can use the random UUID generator and do something like this. Test database and do some string interpolation and random UUID. It doesn't want to automatically import for me, so I'll import that from the crypto package. Missed a word, from crypto. There we go. And this is going to have a bunch of dashes in it, which I don't want. I just want it to be a string of numbers and letters. So we can replace, and that is a built-in JavaScript function, replace all of the dashes, G for global, with an empty string. So that'll get rid of all of those. And then just give us test database with a string of random numbers and letters. Now that we have a test database name, we want to create a URL for our test database. So here we are. And this will look pretty similar to our other URLs. But instead of todos, which was our database name, we are going to plug in our test database name. So this will be our connection to our test DB. And then what we need to do is connect to Postgres with the admin database URL and then create a new database with this connection. So what that's going to look like is we need to set up an admin pool. And let's see if I can get that import from PG. There we go. And then the connection string will be the admin database URL. Then we can create a query to create the database. Using the admin pool.query, we can run some SQL, create database, and string interpolation to get our test database name in there. So we're connecting with our admin pool. We're creating a test database with this name. And then we can disconnect from our admin pool. We don't need that anymore. Now we want to connect to this new database that we just created. So we can use Drizzle to do that. And this syntax will look familiar. The connection string of our test database URL, and then the max number of connections of 10 again, and an idle timeout of 30,000 milliseconds. And then we're able to create our database environment with Drizzle from node Postgres, provided that pool. And then we can use we want to import our schema too. So let's bring that in. Import star as schema. There we go. Provide it the schema, and then also set our casing to snake case, and that's what we've done everywhere else. Now we need to run our migrations on our newly created database. So just to recap, we have created a test database. We're connecting to it with Drizzle. We're going to then run our migrations. And that's not what I wanted. Need to get the correct import here. Import migration, or sorry, migrate. See, Drizzle ORM node Postgres migrator. All right, there we go. Now I can say migrate, provide it the test database, and then we need to provide it the migrations folder, which is here inside of this Drizzle folder. So we can say migrations folder and then provide it the path to get there. And we're actually going to need to join, import that join function in order to help us build out this path. We can say dir name is the current directory name, and then // database / drizzle. And that should do it for us. Now we can return the pool database and test database name. And the reason why we're going to return all three of these is because when we want to tear down our database later, we're going to need to know the name and then access the pool, and then we can use the database to run our queries in our tests. So now that we have a function to create our test database, let's make a function to tear it down after our tests have run. So we can create our function, and this is going to require the pool that we're exporting here, and then also the test database name needs to be provided. And then what we can do is end the current pool connection. And this is the connection to our test database, or end that pool. And then we can connect to our database with the admin pool. Using our admin database URL that we set right up here. And now that we're connected as admin, what we want to do is end all connections to the test database. That way we can drop the database. If there are any active connections, we won't be able to drop it. So to do that, we can run a query. And I'm going to type out some SQL here. So we'll need to select pg terminate backend process ID from pg stat activity. And this references all active connections. So we are going to terminate all processes, all active connections, and we want to specify to our test database. So where dat name equals 1 and the process ID does not equal the current connection. So we want to end all connections except this query, not the active query, to our test database. So this $1 is a placeholder, so we need to provide the test database name here, and that will get plugged into our query. So then we now have our test database, has all of the connections canceled, and we can officially drop the test database, completely deleting it. From our admin pool query, we can drop the database if exists, and then plug in the test database name. There we go. And then finally we can end our admin pool connection. There. So now we should be able to create a test database and then end it after we run our tests. So let's give that a try. I also see, so TypeScript is saying that these are classified as any right now. So in order to make TypeScript happy, we can add a type. So let's see what we can do here. Let's set up a test database context. The pool is of type pool, which is our Postgres pool. And then our database is the node PG database from, there we go, that's the one from Drizzle ORM. And we can provide it the type of schema, so it's aware of our schema in particular. And our other variable down here, test database name, well, that's just a string. All right, now we can say that this is going to return that context, and then use that same context here. So there we go. Now TypeScript is happy and it understands what our pool and our test database are. Perfect. So now that we have the functions to set up and destroy our test database, let's go back over to our queries test and put these to use. So what we're going to need here, Bun has a before each and after each function. Let's go ahead and bring those in. Before each, after each. So let's say for each test, we want to set up a new test database. And we'll say context equals, and we're going to bring in our create test database function. So that should then give us our context. We'll want to set our context as a global variable up top. That way it can be accessed in both the before each and after each. So that'll be test database context, and we'll bring that type in. So now TypeScript is happy. We're setting that variable there. And then we want to mock our current database with this test database we now have. So we can import mock from bun test, and we can mock out the entire database module, database/dbts. So instead of connecting to our local, we will connect to the test database, and we can return db of the context dot database. Cool. And then before each and our after each. Here we'll also make it async and bring in our destroy database function, destroy test db. There we go. And we want to provide that same context object here, so it knows to destroy like the specific test database. Cool, let's save that. And let's go ahead and run these. Well, we only have one test, so let's run our one test. And let's see what went wrong. Should insert a to-do, and key user ID is not present in the table. Now, that makes sense, and that is because now, here in our test, before we were using this hard-coded user ID, and we knew that existed in our local database, but in this new test database, it doesn't exist. So we need to first create a user, and then we'll be able to create a to-do for that user. Let's jump back over to our queries TS file, and we can create a new query to insert a new user. That way we'll be able to get our test working again. And to create a new user, we'll need an email and a password. And both of them will be strings. And then we'll need to hash that password. And Bun has a built-in password hashing function, which is very handy. And if you want to know more about password hashing and authentication, I have a separate in-depth video where I talk about how to set up authentication from scratch and what password hashing is. You can check that out. So I'm not going to go into depth with it here since I have a separate video. And then now that we have a hashed password, we want to insert our user. So we can take our database dot insert, and we're going to insert into the users table, and then we pick our values, and our values will be the email and then the password hash. And then we also want to add returning here. So now if we hover over, TypeScript should tell us what we're getting back. We're getting a user inside of an array. So we saw that right here where we destructured out of that array. So let's do that same thing. And then we can return the user.id. And to be very specific with TypeScript, we can also say that this is a UUID. There we go. So that should insert a user for us. If we jump back over to our queries test, then in here, we can say await insert user. And then, of course, we're taking our email and our password. So let's just say test@test.com and password 123. And then we want to get that user ID. So user ID. And if we hover it over, TypeScript knows that this is a UUID. So that's looking great. And then instead of using this hard-coded UUID, we use the user ID that we just created and saved to the database. So let's go over this real quick. We're inserting a user. We're then creating a to-do. We're inserting that to-do with that user ID. And then we should get back an ID for that newly created to-do. Okay, so save the file. And we are doing all of that with our test database, and then we're destroying our test database at the end of the test. Cool. There's a lot going on. Let's run it again. And there we go. So all of that work, and now our tests are running, and we have a really solid test setup. So as we continue to write more tests, then they're not going to conflict with each other, collide, because one test is inserting data that impacts another test. We don't need to deal with that anymore. Now let's write a test for our getToDos by user ID function. So we can create a new describe block, get users by ID. And then inside of here, we can make a happy path test where it should return to-dos for a given user ID. This will be async. And we'll do something similar where we're going to need to create a user. So we can take this, and there shouldn't be any collisions, even though we're using the same email here and here, because we're spinning up that new test database with each test. Then let's insert two to-dos for this user, and then we can use our query to fetch all of the to-dos. So let's go ahead and copy this here. So we have test to do 1 and double that, and test to do 2, test to do 2, and we can insert that one and insert that one, and we actually don't need the const there. We just want to plug those two into the database, and then we can call our function that we're testing here, get to-dos by user ID. And I put the wrong thing in there, so fix that. Get the to-dos by user ID, and then we have the user ID right here that we plug in. And now this should give us a list of to-dos. Hover over, and we can see TypeScript is helping us out. Yep, we're getting that array of to-dos. So now we can, let's go ahead and just console log our response so that we can see what we're getting back. Do bun test and take a look here. So sure enough, we're getting an array with 2 to-dos. Perfect. This is exactly what we're looking for. So we can assert that we're getting back an array of length 2. That should make this test pretty solid. Expect to-dos dot length to be 2. And then run our tests again, and they are passing. So the next thing I want to show you is how to reset our database. So if you've ever done some database work and you've been testing some migrations and all of a sudden you've messed up your local database and you don't want to deal with it, you just want a reset script that will tear it all down, recreate the database, run the migrations, and run the seed script. So that's what we're going to do. Set up a reset script so that we can easily get our database back into a working state if we were to ever mess it up. So to do that, we're going to do something similar to what we did with the test database, and we're going to connect with the admin URL again. We're also going to need the todos database URL, so we'll pull that out. And better yet, instead of target, I'll call it todos URL. And then this URL, it has todos at the very end. So we want to kind of pop that off and make sure we're getting the database name. So we can do that by splitting on the slash and then popping off the last item in the array. And that'll give us that todos string, which is the name of our database. And then we're going to have a couple different steps here. So first, we're going to want to drop and recreate the todos database. Then after that, we'll run migrations and then run the seed script. So let's make a drop and create database function. And inside of here, we'll connect with the admin URL. And let's see if I can get this import. There we go. Admin database URL. And then we'll need to disconnect any connections to the todos database. So this will be pretty much the same logic that we had here. So I'm actually going to copy paste this. Instead of terminating all connections to the test database, we'll terminate all connections to the todos database, which is our local running database, and then we'll drop the database if it exists, which DB name would be our todos, and then we want to recreate it. So we need another query in here before we close that connection. And we'll create it with the same name. So a new todos database. We're ready to go. Perfect. So that covers it for our first function. Then, like I was saying, we'll need to run the migrations again. So let's make a function to do that. And what we can do here is connect to our pool. And we are going to connect to our to-dos database because that's where we want to run the migrations. Freshly created database, it has no tables now, so we got to add those tables in. And then we can use Drizzle to create a connection. And we'll need to get our schema imported here. There we go. Add that schema and then add our snake case as well. Now that we have our Drizzle connection, we can run our migrations. There we go. I think we got the import. Yeah, from the migrator. Perfect. Pass it the database and then point it to the migrations folder. I'm looking for that path.join. And we can say the directory name, and then we can point to the source / database / Drizzle. There we go. And then we can end the connection to this pool. All right, that covers our migrations. Then we want to run our seed script. And we can actually call our script from our package.json. And then use this exec sync function to say npm run database seed and inherit. And that will run our seed function. And then finally, we can run all three of these functions back to back in a main function. And add some logging. The logs are nice because it helps show us which stage it's at as it's going through. And if it happens to break, then it becomes easier to debug which step broke. And then seeding database ... as it works. Await, run seed, call that final function, and then we can have a completed And then we can call that, and we can catch if there is some kind of error. All right, fix that import. Now, before we run our reset script, let's go ahead and pull up Drizzle Studio again. This way we can take a look and see how many to-dos we have in the database, and then we can look before and after to make sure the reset is working as expected. So now looking at Drizzle Studio, we can see that we have 104 to-dos here, and that's because we seeded 100 and then we had 4 additionals from doing some testing. So when we reset this database, we should go back down to 100 here, and this should be 10. So let's go ahead and give that a go. And the next thing we need to do, I had actually forgotten, was that we need to add our reset script into our package JSON next to our seed script. There we go. Now we can go ahead and run and see what happens. So we can see that it dropped and recreated the database, it ran migration seeding, and the database reset was complete. There's an error message here. I'm not quite sure why that was, being that it said it completed successfully. So let's take a look at Drizzle and see if our reset was successful. And check it out. Back here in Drizzle Studio, we can see that we're back down to 100 to-dos. So we went from 104 down to 100, which means our reset was successful. So that's great news. If we ever mess up our database, we've got a script we can run and get back into a working state. So now that we have our local database all set up, I want to bring this full circle and come back to our Hono router. And let's say that we want to put our queries to use. So let's make a route to get all of the to-dos by user ID. So let's clear out this generic hello Hono and say we want to get the user ID off of a query param. So let's say user ID equals c.request.query, and we'll say it's user ID. And then we can do a try catch, and we'll get our to-dos by importing our query get to-dos by user ID, and then plug in our user ID here. And it looks like that's upset because this is not async, so that should make it happy. And this argument of string or undefined is not assignable. All right, that's reasonable because somebody could leave that string off. Let's say if there is no user ID, then we'll return early, and we'll say no user ID provided, and we'll say it's a 400 bad request. Otherwise, we'll go ahead, we'll fetch those to-dos, and we'll return that list of to-dos and say 200 good request. And if there's some other kind of error, we'll do a console.error and do a log for us on the server, and then also return an error message back to the user. And it's common to use internal server error of 500 when we get some kind of unexpected error. And this is saying type string may not be UUID. So just to make TypeScript happy, we'll say as UUID. And if it's not a UUID, our database will throw an error, which will end up getting caught here. So there is probably a better way to do a little bit more robust error handling around the query param. We could use Zod, but for this tutorial, this video, I wasn't planning to dive into Zod. I have a separate video on that, so I wanted to focus on the database and Drizzle here. So now that we have this endpoint up and running, we can give it a go and see if everything works as expected. So to test this out, let's run our server. So we can do bun run dev, and there we're up and running on localhost 3000. And we can create an index.htp file, and this file works with the REST client extension. So if you have this installed, you can create one of these files and it will send requests directly from VS Code, which is super handy. So we can say HTTP localhost 3000 / todos. That's our route. And then we added a query param of user ID equals, and then I copied a user ID from the database. So here we have one. And when I save, we can see we have the send request right here, and we can give it a go. And would you look at that? All right, we got a 200 OK, and we got the IDs, or not the IDs, the to-dos for this user. We've got a list of all of the different to-dos, keeping things clean, and etc., etc. So that's awesome. We've come full circle. We have set up our database, set up our schemas, made our migrations, and created our queries, and then connected those queries to a route inside of Hono. And it was a lot of work, but if you stuck with, I hope you feel proud of yourself, and hopefully this helps you with your own setup so that you can get Postgres running with your own Hono app.